morning, guys. We're here at Galino Court and we're going to try to have the perfect three-point shot. I'm Alex.
I'm Rubeline.
I'm Jenison.
I'm Chrysler.
We are
The Repels!
So we're going to try to have the perfect three-point shot using physics. So let's see how it goes. Before we begin, let's first try to have some three-point shots without any knowledge of the physics.
Okay, let's go! Kapagod pala mag-basketball. Ulit na lang ako nagsushoot. Hindi naman ako nakaka 3 points. Tapos, di ko pa alam kung paano hawakan yung bola. Tapos, di ko alam kung ano ba yung tamang angle. Tapos sa letong to, parang imposible na maka 3-point shot. Kung tanungin ko kaya kay Saber, kung paano maka 3-point shot, gamit yung basic concept sa physics. Dika, lapitan natin sila. Saber, paturo nga kung ano yung pwede kong tandaan kapag nagsushoot na para maka 3 points.
Sige, tara, doon tayo sa ring.
Diga.
Okay, now let's try to find the velocity at which the ball needs to attain for it to reach the hoop. So, let's use the basic kinematic equations. But first, let's try to find the components. For the horizontal component, or the initial velocity in x, it would equate to the initial velocity cosine theta. For the vertical component, initial velocity in y is equal to the initial velocity sine theta. Now, let's try to find time of the ball in the air using x. X is equal to the initial position plus the velocity of x multiplied to time plus 1/2 multiplied to acceleration times time squared. Now, since our initial position could be 0, we could cancel the first part of the equation, as well as our acceleration on the x-axis is 0, we could cancel the third part of the equation, which would give us the equation x is equal to the velocity of x multiplied to time. And here, we could get the equation for time, which is equal to time is equal to position or x all over the initial velocity of x. Now, let's try to substitute this equation to our y component. Now, y is equal to the initial position in y plus the initial velocity of y multiplied to time plus 1/2 gt squared. G stands for gravity, and as we all know, the accepted value for gravity on Earth is negative 9.8. The initial y position is equal to the height at which the ball is released. Now, let's substitute our given constants. Now, for the y value, or the height of the hoop, that would be 3.05 meters. For the distance of the player or the ball from the hoop, or x, that would be 6.75 meters. Now, our participant here, Jenison, his height is 1.5 meters, which is the estimated value at which he would launch the ball. Now, let's try to plug in different angles to this equation as well. Let's first use theta so that later on we could change it to different values.
Now, here is already derived formula. If you want to see the full derivation of this formula, please refer to our paper. Given this function, we could have this table as the representation
of when we have two different heights, 1.5 and 1.6, 1 for when Jennison doesn't jump, and 2 for when Jennison jumps. We'll also have 3 different angles, 40, 45, and 50 degrees. And the result? Thank you for watching the vlog of Grade 12 Graviton Repels. If you have any questions, please comment down below. Thank you and have a great day.
So hi guys, now I'm gonna do our physics lab report with the help of my groupmates of course, but since me and CJ were compiling it and like doing the research on it, that's why now I'm doing the lab report. I'm starting, it's not seen, cannot be seen, I'm already starting and I'm already talking to CJ or Chrysler.